find it.
No, we are in the wrong floor.
Wrong floor, okay.
Wrong floor.
Right. Oh, look, are these free apples? We can take an apple? Oh,
No, wrong mathematician. Eventually, we got there.
so this is where the Bernoullis would have done some of their mathematics of an
Yes.
evening.
I was really just being polite. I'm not sure we should have bothered. The only thing of interest was an old stove.
Now, of the Bernoullis, which is your favourite?
Yes.
Favourite of
Also,
the
my
Bernoullis?
favorite Bernoulli is Johann I. He is the most smart mathematician. Perhaps his brother Jakob was the mathematician with the deeper insight in the problems, but Johann found elegant solutions.
The brothers didn't like each other much, but both worshipped Leibniz. They corresponded with him, stood up for him against Newton's allies, and spread his calculus throughout Europe.
Leibniz was very happy to find two gifted mathematicians outside of his personal circle of friends who mastered his calculus and could distribute it in the scientific community. That was very important for Leibniz.
Yeah.
And important for maths too. Without the Bernoullis, it would have taken much longer for calculus to become what it is today, a cornerstone of mathematics. At least that is Dr. Nagel's contention, and he's a great Bernoulli fan. Tonight, he's arranged for me to meet Professor Daniel Bernoulli, the latest member of the family, whose famous name ensures he gets some very odd emails.
The other one which I got was Professor Bernoulli, can you give me a hand with calculus?
Yes, exactly. To find a Bernoulli, then you expect them to be able to do some calculus.
But this Daniel Bernoulli is a professor of geology. The maths gene seems to have truly died out. And during our very hearty dinner, I found myself wandering back to maths. It's a bit unfair on the Bernoullis to describe them simply as disciples of Leibniz. One of their many great contributions to mathematics was to develop the calculus to solve a classic problem of the day. Imagine a ball rolling down a ramp. The task is to design a ramp that will get the ball from the top to the bottom in the fastest time possible. You might think that a straight ramp would be quickest, or possibly a curved one like this that gives the ball plenty of downward momentum. In fact, it's neither of these. Calculus shows that it's what we call a cycloid, the path traced by a point on the rim of a moving bicycle wheel. This application of the calculus by the Bernoullis, which became known as the calculus of variation, has become one of the most powerful aspects of the mathematics of Leibniz and Newton. Investors use it to maximize profits. Engineers exploit it to minimize energy use. Designers apply it to optimize construction. It has now become one of the linchpins of our modern technological world. Meanwhile, things were getting more interesting in the restaurant.
My second surprise, may I introduce Mr. Leonhard Euler? Daniel Bernoulli.
Leonhard Euler, one of the most famous names in mathematics. This Leonhard is a descendant of the original Leonhard Euler, star pupil of Johann Bernoulli.
I'm the 9th generation and the 4th Leonhard in our family after Leonhard Euler the first, the mathematician.
Okay. And yourself, are you a mathematician?
Actually, I'm a business analyst. I can study mathematician with my name.
Everyone will expect you to prove the Riemann hypothesis.
Perhaps it's just as well that Leonhard decided not to follow in the footsteps of his illustrious ancestor. He'd have had a lot to live up to.
I'm going in a boat across the Rhine, and I must say I'm feeling a little bit worse for wear this morning. Last night's dinner with Mr. Euler and Professor Bernoulli degenerated into toasts to all the theorems that the Bernoullis and Eulers had proved, and by God, they proved quite a lot of them. Never again.
I was getting disapproving glances from my fellow passengers as well. Luckily, it was only a short trip. Not like the trip that Euler took in 1728 to start a new life. Euler may have been the prodigy of Johann Bernoulli, but there was no room for him in the city.
If your name wasn't Bernoulli, then there was little chance of getting a job in mathematics here in Basel. But Daniel, the son of Johann Bernoulli, was a great friend of Euler and managed to get him a job at his university.
But to get there would take 7 weeks, because Daniel's university was in Russia. It wasn't an intellectual powerhouse like Berlin or Paris. But St. Petersburg was by no means unsophisticated in the 18th century. Peter the Great had created his city very much in the European style, and every fashionable city at the time had a scientific academy. Peter's Academy is now a museum. It includes several rooms full of the kind of grotesque curiosities that are usually kept out of the public display in the West. But in the 1730s, this building was a centre for groundbreaking research. It's where Euler found his intellectual home.
I'm sure that there could never be a more potential man than me.
Many of the ideas that were bubbling away at the time, calculus of variation, Fermat's theory of numbers, crystallise in Euler's hands. But he was also creating incredibly modern mathematics, topology and analysis.
Much of the notation that I use today as a mathematician was created by Euler, numbers like E and I. Euler also popularised the use of the symbol pi.
He even combined these numbers together in one of the most beautiful formulas of mathematics. E to the power of I times pi is equal to -1, an amazing feat of mathematical alchemy.
His life, in fact, is full of mathematical magic. Euler applied his skills to an immense range of topics, from prime numbers to optics to astronomy. He devised a new system of weights and measures, wrote a textbook on mechanics, and even found time to develop a new theory of music. I think of him as the Mozart of maths, and that view is shared by the mathematician Nikolai Vavilov, who met me at the house that was given to Euler by Catherine the Great.
Euler lived here from 66 to 83, which means from the year he came back to St. Petersburg to the year he died. And he was a member of the Russian Academy of Sciences and the greatest mathematician.
Right.
This is exactly what it says.
What is it now?
Now it's a school, actually.
A school?
Yeah.
Should we go in and see what's...
Okay, yeah.
I'm not sure Nikolai entirely approved, but nothing ventured.
Perhaps we should talk to the head teacher and see whether we can...
Здравствуйте, мы пройдем к директору.
The head didn't mind at all. I rather got the impression that she was used to people dropping in to talk about Euler. She even had a couple of very able pupils suspiciously close to hand.
These two young ladies are ready to tell a few words about this scientist and about this very building.
They certainly knew their stuff. They'd undertaken an entire classroom project on Euler, his long life, happy marriage, and 13 children. And then his tragedies. Only 5 of his children survived to adulthood. His first wife, who he adored, died young. He started losing most of his eyesight.
So for the last years of his life, he still continued to work, actually. He still continued his mathematical research.
Yeah, I read a lovely quote that said, now with his blindness, he hasn't got any distractions and he can finally get on with his mathematics.
Yeah, this is what he said, yes.
Very positive attitude.
Actually,
It was a totally unexpected and charming visit. Although I couldn't resist sneaking back and correcting one of the equations on the board when everyone else had left. To demonstrate one of my favourite Euler theorems, I needed a drink. It concerns calculating infinite sums, the discovery that shot Euler to the top of the mathematical pops when it was announced in 1735. Take 1 shot glass full of vodka and add it to this tall glass here. Next, take a glass which is a quarter full or a half squared and add it to the first glass. Next, take a glass which is a 1/9 full or a third squared and add that one. Now, if I keep on adding infinitely many glasses where each one is a fraction squared, how much will be in this tall glass here? It was called the Basel problem after the Bernoullis tried and failed to solve it. Daniel Bernoulli knew that you would not get an infinite amount of vodka. He estimated that the total would come to about 1 3/5. But then Euler came along. Daniel was close, but mathematics is about precision. Euler calculated that the total height of the vodka would be exactly pi squared divided by 6. It was a complete surprise. What on earth did adding squares of fractions have to do with this special number pi? But Euler's analysis showed that they were two sides of the same equation. 1 plus a quarter plus a ninth plus a 16th and so on to infinity is equal to pi squared over 6. That's still quite a lot of vodka.